All right, hello everybody. We are the Echelon sponsored senior design team. My name is Nate Pixley.
I'm Ruben Lopez.
Reese Robertson.
Jake McClenny.
Johnny Sakarni.
Echelon asked us to design a system that exhibits an innovative application for Internet of Things technology. Now, upon brainstorming this proposal, we noticed that IoT in the home environment is already being explored by several companies. And as a forward-thinking team, we really wanted to explore uncharted territory.
I don't know about you, but a common experience of mine is waiting in long lines at Safeway. The current checkout method is inefficient and outdated, and not even self-checkout is able to solve this problem.
So we put our heads together to try to come up with a solution. And our idea was to parallelize the checkout process by developing an internet-connected smart shopping cart that lets you scan as you shop. Our goal is ultimately to simplify the shopping experience, and our vision is that the customer can walk up and down the aisles while scanning items as they add them to their cart, and walk out of the store to be billed appropriately. Now, if I can direct your attention behind me, we have a live camera feed from Nate here to help some of you in the back of the room get a better view of the cart itself. To start with, we have a built-in barcode scanner to identify barcoded items inside of the store. The cart can also verify when the correct item has been placed inside, as indicated by the green LEDs.
So this one takes care of some of the items in the store. We still need a way to identify non-barcoded items, such as produce. The cart has a special mode just for this. We've equipped it with a camera to take pictures of produce items. Then, using computer vision technology, we're able to determine the color and shape of the object and narrow down the possible choices for the customer.
If you'll bear with us for a moment, sometimes the processing takes a little bit of time because image recognition is computation heavy, and a Raspberry Pi doesn't quite have the horsepower to deal with it. It's one of our planned future improvements.
Once it's finished computing, it generates a small list of items based on the results. From here, you simply select the item you wish to purchase, or take a new photo if necessary, and place it on a scale.
Items weight automatically, as shown on the bottom of the screen. Once Reese pushes accept, the item is added to the shopping list, and a running total is updated. This is accomplished using strain gauge load cells to not only weigh produce, but also to prevent theft. Say someone tries to steal an item by placing an item that hasn't been scanned. The cart knows that the wrong item is inside, as shown by the red LEDs and a warning on the display. You can't continue shopping until you take out the item. Another way someone may try to steal is by scanning one item in and placing a more expensive item inside. Once again, the cart detects that the foreign item has been placed inside, as shown by the red LEDs and a warning message on the display. You won't be able to continue shopping until the correct item is placed inside.
This is accomplished with a database lookup. Every time the cart scans an item, the cart contacts our SQL database to retrieve item attributes, such as the expected weight and price of that item. This allows the cart to compare the expected weight with the actual weight at all times. As you can see behind us, we're also using the database to monitor cart contents and the weight in real time. This can be used by employees or management to supervise all cart activity, such as theft behavior, scan times, or even the location of the cart.
Now, we can use the web page to monitor every active cart individually. By selecting a cart from the drop-down menu, we're brought to a page that displays information about it, including its contents, location, and if you look down at the bottom, there's expected weight, which is the sum total of all the items in the cart as calculated by values stored in the database, plus the produce inside the cart, and then the actual weight, which is being measured directly by the cart. Now, you notice that these numbers are slightly different, and we have a warning sign that's telling us this. A slight deviation may be due to a small deviation in a natural deviation in the store's products or potential theft activity. Now, if you look at another cart, we might see another warning. And this one is letting us know that the cart has been in lockdown mode for an extended period of time and that shopper might need assistance. Now, moving on, the system is also capable of easily expanding the store's inventory. Now, this item is not in the database, and I can demonstrate that by scanning it with the cart right now, and it will reject it. Now, we understand that a shopper would never encounter an unrecognized item on the shelf, but we really just want to demonstrate how easy this process is. So I can come over here to the inventory adding module, scan the item, place it on the cart, on the scale rather, allow the web page to register the weight and the barcode number. We give the item a name and a price, and immediately upon confirming this database entry, we'll be allowed to successfully add to the cart.
Moving on, our system is also capable of observing metrics or analytics of shoppers' activity. Every time we scan an item, we're logging the item name and the scan time. If we look at our scan history over here, we can see the breakdown of items we scanned since the beginning of our project. We can even filter these results just to see today. Here's all the items we've scanned today in a similar breakdown. This kind of information can be used to recommend popular items to a shopper as they're going around the store. Let's look at an example of this. We go over to our suggestions window. We can see currently nothing's there. Tony, why don't you go ahead and scan an item?
Barcode scanners. Not getting this. I wonder what sauce would go good with this pasta. Oh, that looks good.
As you can see, the network knows what he scanned, and it can recommend the appropriate item. Moving on, our system is also capable of building automation features, such as energy-efficient lighting control. As you can see around us, we have Echelon Wi-Fi boards interfaced to LED lights, which will remain in a power-saved dim mode unless a cart is nearby. When a cart comes within a certain range of the lights, a message is sent over the network to brighten the lights in that area. This is accomplished with Echelon's hardware and software platform and Bluetooth low energy beacons. This type of technology can also be used to trigger location-based events. We go over to our location-based events tab. We see nothing is there. Currently, if we scroll down, we can see that he's in aisle 2. Let's see what happens when Tony goes over to the produce area, which is aisle 3. Keep in mind that the network knows where he is, and it knows what's in his cart. As you can see, once again, the cart knows where it is, it knows what's in the cart, and it can recommend appropriate items nearby in that area and pair them with existing items in the cart.
So, now that we've given you kind of a rundown of what our cart is capable of, we want to go into a little more detail about how it actually does it. As we mentioned before, location services utilize Bluetooth low energy technology. We set up our Bluetooth devices as beacons, which broadcast their identification information. The software then decodes this signal and processes the received signal strength indicator to determine approximate distance.
As mentioned, we're using Echelon's hardware and software platform. Here we have Echelon's CPM 4200 Wi-Fi board, which communicates with Echelon software on our Raspberry Pi.
Now, for the computer vision, we utilize a variation of OpenCV's face detection algorithm. We generated what are called HAR cascades that the software uses to detect specific objects that we made for our selection of produce. Using this, along with a color detection algorithm that we made, we are able to differentiate between produce items. This is a huge improvement over the current system of scrolling through an entire catalog to find your produce.
Now, as we said before, all this processing for OpenCV happens on the card itself with our onboard Raspberry Pi. This also runs our top-level application, which is multi-threaded and developed in Python. In addition to OpenCV, the Pi is also responsible for controlling the camera and barcode scanner and processing signals coming from the weight scale.
Weight scale is built using 4 strain gauge load cells, which convert mechanical stress into analog voltages. The challenge was to fit the scale inside the cart and have it weigh a range of items from 0 to 150 pounds at an accuracy of 0.01 pounds. We then built a circuit that amplifies the microvolt variations of the load cells and converts it into digital data that we can use. We then built software that filters this data and incorporates it into our system.
Now, to mobilize the cart, the entire system is powered by 11.1 volt lithium-ion battery. This voltage is regulated to 5 volts using a buck converter to accommodate the Raspberry Pi. Current in and out of the battery is integrated over time to monitor its state of charge, and the 4,400 milliamp hour capacity is enough to power the system for just under 6 hours. Now, if we were to move forward with this project, there are a few areas that could use improvements. We would modernize the mechanical design and the graphical user interface and increase the processing speed, and we'd implement the payment system. And in order to facilitate scalable location sensor deployment, we would take advantage of Echelon's CPM 4200 ability to auto-flash BLE beacons via UART. That will conclude our presentation. Thank you for listening. Do you have any quick questions? We weren't inspired by them, but there was kind of like a running joke that's kind of like, how like we were working similar like idea.
I mean, you've taken it a long way further. I mean, I thought, your nice talk of integrating the demo with tech talk.
Have you guys thought about for the husband lost shopper when your wife sends you to go buy a spice and you have no idea where to go? If your system could you type in or have voice activated, I need a certain type of spice.
Absolutely.
Tell me where to go in the store.
Absolutely, yeah, because included with the location sensing, like we imagine the store will have those locations programmed into their database, and so you could type in some product you're looking for, and it will tell you its location right away.
So in the interest of time, let's thank you again.
Thanks.